Okay, I expect you guys have done some video at home, right? Watch the video at home, and I'm sure you will get to know more about this. And today, what you're going to do is to have a practice. Okay, is to have a practice. So that's why. So it is for chapter. Just shall we go back to this, right? Just where are we now? For chemistry, we focus on getting to know the heat change of the reactions. So the measurement of heat change under constant pressure. What we call it? Okay, what we call it as a delta H. Okay, enthalpy change. So this is what I would like to talk to all of you, right? It is our layout, also enthalpy change calculated as the heat change under constant pressure. Okay, heat changes constant pressure. So that's why we come to so many different examples having this. So you are going to use applied Hett's law in this chapter to relate some enthalpy terms in which we cannot determine it directly. What I mean by that directly is by experiments. Okay, for those where not all reactions, not all enthalpy terms can be determined through experiments. Okay, so this is what we stop at that. And today, let's try to finish the remaining exercise and trying to see if you can manage. Now, question 14, take a look. Question 14, just finish the renaming pass. It's sometimes possible to measure the enthalpy cycle directly. So you are going to have that two routes, the direct route and indirect route. So enthalpy cycle, write an equation relating A delta H1, 2, 3, and 4. It's easy, right? So you know what's that? 乜叫藍？乜叫藍？係咪叫藍？係咪要藍？我講。Now, could you please tell me that I don't know how to do? So you are going to have two routes, route 1 and route 2. 孤立行, you just left. Where are you? Do you know how to manage this one? Yes, this is route 1. And we are going to have what? Route 2. Yes, from this direction. Good. So how can you relate that delta H1? Now, this is the starting point, while this is the finish point. So you have got two routes, right? One is here and 2 another here, right? 2 is here, right? So what you're going to do is to relate the two in mathematics. Yes, that's right. Delta H1 equals delta H2 plus delta H3 plus delta H4. So depending on the direction of arrow, right? If we go with the same direction, just put a plus. Okay, what will happen if we go into reverse direction? You are going to write down a minus sign, okay? Because the reverse reaction, the delta H value is just the minus of those data. So explain the meaning or the understanding of the term Hett's law. Anyone who still know what is that? For those who know it, could you please type it onto a chat box? Let me know. What does Hett's law states? Hett's law, what does the Hett's law state about the delta H of reaction? What is that? Yes, the total enthalpy change of a reaction is what? is independent of the routes they would take, right? Yes, that's right. Okay, so this is what I would like to talk to you. So remember, there's got assumption. The assumption is the initial condition and final condition must be the same. Okay. So what is meant by that condition? So you usually would say that type of equating those FOP terms by standard condition. So what is meant by standard condition? It is a fair comparison, right? To compare data. What is meant by, yes, that's right, 298 Kelvin, 1 ATM. So this is what we mention it as standard condition. Okay, standard condition. So this is what I would like to remind all of you. Questions? Warm up. All those that are just warm up, right? Feel easy, right? So here comes next part. A little bit more difficult. Here comes the calculations. State Hess law. I don't want to state it once again. I'll just give it. How about B? B-foul ethane rate is liquid S star. So write the chemical equation including stick symbols for the reaction, but with the enthalpy change equal to the enthalpy change of the formation of methyl methane rate. So what is mean by that? You just write down the equation showing delta H of formation, right? Of methyl ethane rate. Do you still remember what is mean by methyl ethane rate? What is that? You still remember? Yes, you have got. Oh, that is not correct. Okay. So what is that? CH3, CH2, COO, CH3. Is it correct? Is it correct? What is mean by ethane rate? It comes from the word ethanoic acid. Okay, ethanoic acid. Where is ethanoic acid? Yes, that's right. One carbon more too much. So you are going to find out CH3, COO, CH3, methyl. This part, ethanoic, right? We've got for two carbon. So what is the formation of this? This one, it is a, what is the physical state? A liquid. So the equation is what? 3 carbon graphite plus what? How many O2? 1 O2, yep. Together with, how about H2? 3H2, because altogether we've got 6H, right? So it is 3H2. Yes, that's right. This is the equation. So use the data to calculate the enthalpy change or formation of this using combustion data. So there are 3 ways. Okay, so there are 3 ways. So which way are you going to take? So somebody love to draw a cycle, right? I will show you I will show a whiteboard, right? All of you can draw. So how is it? So just write down what I've just mentioned. This one, 3 graphite plus 3 hydrogen plus O2 to form CH3, COO, CH3. This is what I would like to find, right? The delta H formation of this methyl ester, methyl ethanoate. So we would like to draw, right, the box again. Give me the box. Yeah. So what I'm going to do next is to relate this this, or that's just backward? What do you want? Combustion, right? So once you see combustion, the arrow should be what? In the reverse sign, right? You will write down combustion. Yes, that's right. You are going to write in reverse. It's not necessary to be always pointing upward. It can be pointing downward. So it depends on the equation you're going to tell. This time you are going to have what? Combustion. Combustion, so you need to add what? The better not solve this part because it's very complicated. Solve this part first, okay? So add how many O2? Now you may find that it's more tricky because those reactant, they also contains oxygen. They also contains oxygen. So how will you draw that diagram? Mathematical answer is easy to get, but the way to draw the cycle, I need to check if you have got it correctly. 2 CO2. Who wrote 2 CO2? Not correct. How many carbons are there? Yes, that should be 3. Yeah. So what's next? You've got 3. 3 CO2. And then water is 3. Is it correct? It's 3. And then later on, you are going to write down oxygen remaining. 3 times 2 equals 6. And then plus 3 equals 9. 9 So minus that 2. Remember, you are going to minus that 2. Here comes 7. So what is the answer for that? 7/2. Do you understand? So remember, you are going to keep that S star. You're going to keep that S star 1 mole. Okay? What is left behind for that? On the right-hand side, left-hand side. Minus that O2. Here comes what? The O2 is exactly that. So what does it mean by that? You're going to add 7/2 O2 as well. Okay, such that we can get altogether 9O. Do you understand? So what's next? Just label the terms on the 2 arrows here. The first one, what is that? 1 mole of this undergo combustion to form this. The whole enthalpy terms, what is that? Delta H of combustion of CH3COO, CH3 liquid. Okay, do you understand? So what will happen to that? So you will use, I will use another one, right? So you may get this 3 carbon, and you use up to what? They will use up 3 O2. Okay, they will use up that 3 O2 to form what? 3 CO2. This is the one. So that's why we write down delta H of carbon C graphite times 3. Okay. Thanks, Thomas, for writing down. And the second one is what? Okay. Why do you cross it out? Don't be shy. Don't be shy. Don't blame too much on yourself. Now, even Hong Jinpan can write. You should have your own courage to write. So 3 times delta H of there should be combustion. Combustion of C graphite. Graphite. How come? So it's very strange, right? Of graphite. And plus something. Plus what? So the remaining O2. Okay, we have got the O2 to react. Okay, there should be 3/2 O2. Okay, by doing so, you add it together. Here comes what? Here comes 9O. So altogether is 9O. So plus what? Plus 3 times delta H of combustion of hydrogen gas. Okay, so you may get, right? So you may cross them out this one because it is the same. is the same as these two data you added together. So what is final way? You are going to relate the two direction, right? Direction 1 here, while direction 2 is what? It is here. Okay? Direction 2 is here. So what you will get? What will you get? A 燒盡氣 too late. So what is the delta H of formation of that S star? You still need me to give you more minutes, right? More than 3. Just write it down. So what is that? Just this one, the same direction. The same direction. 3 times delta H of combustion of C graphite plus 3 times delta H of combustion of hydrogen gas. And finally, because you may find that the arrow is opposite to the original arrow, so you put a minus sign here. Minus what? Minus delta H of combustion of the S star. So the answer is what? Minus 448 kilojoule per mole. Yes, correct. This one is correct. Okay, this one is correct. So do you understand? Now, if you understand, could you please put a tick and let me know? You don't understand, put a cross. How about the others who don't show me your sign? You know it or you don't know it? You don't understand. Zhang Gawen, what is your sign? I did not see it because your name is too long. Oh yeah, I can see it now. You didn't put anything. Mặc dù làm, you just keep on raising your hand. What does it mean by that? 陳子軒, no response. 陳浩希, 蔡仲常, 何展鵬, Ian Go, 郭立恒. But 潘子軒, you're just far away from us. Cedric, why the one who marked the attendance just left? So you she just treated you to be absent. Just left. Just left. Just 1 or 2 seconds. Remember to come back earlier. So what is that? So you get what is that? For those others, right? You better watch the videos for to catch up with all those. Okay. And for those who want to, for those who would like to try it out, to have another tutorial, I can have it, but let's talk about it later today. So we try to take a look on the second questions. Now solve this one. How about this? Punonji, in order to show that you are present, so could you please try out question 16? Question 16, this one. 調查 1,3 diene is a gaseous carbon. 16, why would you say the answer is C? What happened to you? Have you watched the video? Or you just proven, right? You just proven yourself that you haven't watched anything. So how would you tackle the questions? What? Oxidation? Come on, we are now in book 3C already. So next week we would start over the chapter for A. Okay, for A next week. So isn't it a little bit lagging behind, right? So you have to catch up. So 16A, let's try to do it together. Something about definition. Standard enthalpy change of formation with the aid of a chemical equation. So what is meant by the term standard enthalpy change of formation? A very long term, right? So what is that? Chen Wang, have you memorized? Have you memorized it? What is meant by standard enthalpy changed? Or something you're missing, right? What is that? Something missing from elements. No marks already. No marks, no marks. It tells you the enthalpy change when. It tells you enthalpy change when what? 1 mole. Yes, that is the key. 1 mole of something. 1 mole of substance is formed from its constituent elements. Okay, from this constituent elements in their standard state under standard condition. So you are going to list that standard condition here. 290 Kelvin, 180 M. So with the aid of chemical equation. So we will have abbreviation delta H of F like this. Now, suggest why the enthalpy change for combustion formation of C4H6 cannot be determined directly by experiment. So what is that actually? This is 4 carbon, so you need to know the equation first of all, before you judge. 3 hydrogen to form 1 mole of C4H6 gas, delta 13 diene. So why can't we get it directly from experiment? Xiu Junhei, I give you one more chance. Pan Long Ji, hi. I just see that you're going away. Right, tell me, do you know? Why can't I use the method in the last chapter, right? Just like to measure, for example, MC30, measure the temperature rise or drop, or in order to get that delta H formation. Why can't? Why can't? Not accurate. Your answer is not accurate. Heat is lost to the environment. Is it something about the reaction nature itself? Yes, the reaction is not feasible. Yes, that's right. Ho Jiman has got the correct answer. They do not react to form C4H6 from this under this normal condition. So you cannot. So which means that even though I have 4 mole of carbon, 3 mole of hydrogen, okay, and place it here, they would not react to form C4H6. So that's why this enthalpy terms cannot be determined directly by experiments. Okay, so simply speaking, the chemicals will not be formed. The product cannot be found as C4H6. So of course we cannot measure. C, you're going to draw the cycle, right, again, and use this data to find out the formation of butyl 1,3-diene. Remember, sometimes you are asked to draw the cycle, and you are going to find out the formation of butyl 1,3-diene. Okay. So once again, now I would like to draw the 3 boxes here, right? I will show you the 3 boxes here. So tell me, what is that? What should be filled in for those 3 boxes? How many carbon and hydrogen for the left-hand side of the boxes, Channel 1? Could you please continue? Yes. Good. Quite nice, good start. And indeed, you miss out something. You miss out what? The stick symbol. You are going to write down stick symbol. Yes, solid. Is it just solid? For carbon, which is the most stable form of carbon? Yes, graphite. Very good. Okay, Channel 1, you have done a very good job, right? This time. So graphite, you're going to write down this gas and together with an arrow like this. Okay, and to form this, and then you are going to final 11/2O2. Yes, that's right, to form this, and this one you're going to burn it. Okay, you're going to burn it. 11/2. So 11/2O2. So how about the one on the left hand side? So how many O2 should there be? What is that? I cannot see it. It's 4O2, right? 4O2 and 3/2O2. Yes, that's right. This, and this. Yes, that's right. So the remaining is to fill in the labeling of those 2 arrows. What is that? So what is that? Yeah. So you better, I would like to use different colored pen such that all of you can keep track of what is happening. Now, first of all, the pink one, just continue. I would like to use your word. Now, first of all is on this part. Take a look on the right-hand side first. So the C4H6 plus 11/2O2 to form 4 CO2 plus 3 H2O. What is the enthalpy terms? The whole thing. What is that? We will call that delta H of combustion of C4H9, H6, sorry, C4H6. Okay, gas. This is the enthalpy terms. If you write down as an equation, you may get this enthalpy terms. This is the first one. How about this? This arrow, it is indeed made by 2 arrows. Okay, so that's why Chang He has been split that into 2 parts. One is O2, the other one is 3/2O2. So I would like to share with you this part for O2 together with 4 carbon graphite. Okay, so what is that? You're going to talk about delta combustion of graphite times 4. Can you see the word times 4? So once you mark it as times 4, so what is that? So you will form 4 CO2. 4 CO2. Can you get it? So next, what is that? We've got 3 hydrogen, 3/2O2 to form 3 H2O. So what is that? We have got that another enthalpy terms. Remember to times 3. Why is it times 3? Why is it times 3? Because we have got 3 mole of hydrogen. So for the 4 mole, okay, so for the 4 mole, it is, you may see it directly, it is 4 times 4. Okay, for this part, why did we need to times anything? Indeed, it is just times 1, so because it's just 1 mole. Okay, is that clear? So to use the same idea to for calculations. So Zhang Gaowen, could you please tell me the answer this part? Can you come up with the answer? Zhang Gaowen. So how would you get that? So this is the what we want. Step 1. Step 2 is on this part. Step 2, right? The root 2 is on this. You are going to follow this step to come up with the answer. So what is that? So you are going to have delta H of formation of C4H6 gas, which is equal to what? Which is equal to this sign, right? So just you copy it. Delta H of combustion of C graphite times 4 plus delta H of combustion of hydrogen gas times 3. This one reverse sign, right? Reverse. So you're going to minus that. Minus delta H of combustion of C4H6. So you will get the answer. Yes, that's right. It's a 0 plus 108 kilojoule per mole. That is the answer. Question? Okay, question? Okay, for those who understand, now could you please, this time, I need to double check if you really are with us. Now, could you please put a thumbs up if you know it? If you thumbs down, you don't know it. Thumbs up, you know it. 6 of you know it. You understand? You still don't understand? Zhang Gaowen don't understand. Chen Gei, what? You just play around with the icons, right? You play so happily. You just open the computer and go away. Let's have some contribution.
先生喺度啊，喺度喺度。
How about Cedric? Cedric Poon? Poon Oji? Where are you? Mr. Chan? Ian? Ian don't know. Marcus? You simply put me across. What is that? Poon Ziyin, are you with us? Hey, Wang Yufeng? Well, we have got one Form 3 student sitting in the classroom. Is it Godwin? Godwin Wang? Form 3? Oh, welcome. Or if you really understand, you can just sit here and listen, right? So how about the others? You know it? You know the game to play, yeah? It's easy. A little bit. I must say that is something fundamental. And I would like to show you something more complicated. Right? This is just the start. It's not that difficult. It's just basic stuff, I must tell. But some will say that, Mr. China, are you kidding? Basic? How come it's so, it seems it's so difficult, right? So I'd like to show you about this part. Another one. I would like to show this. Okay. 16 already done. How about these 2 questions? Have you done that? Have you done that? 17 and 18, very similar. Okay, very similar. for that too. Don't know. All right. So take a look of, because Godwin is here, I would like to show you something very, very basic and fundamental, 17 and 18. Just continue 17 and 18, such that you at least you understand some part of that. What is that? 17. 17, it is 17 is this reaction, right? And ethene, for the others, senior brothers, don't let me know that Godwin will finally understand earlier than you. 17, ethane burns with a limited supply of oxygen to give carbon monoxide and water. Very strange reaction. You will see the product, carbon monoxide and water. So the enthalpy change for this reaction cannot be determined directly. Can be found using the enthalpy changes of combustion of ethane and carbon dioxide together with Hess law. Okay, so we first change and explain why enthalpy change of a buffer cannot be determined directly. This one, why can't we get it directly? You just write down CO2 and the answer is incomplete. Now, could you please elaborate more? Please elaborate more on this part. The reaction may give out CO2. Yeah. Okay. Yes, that's right. You also produce CO2 and also what? There may be some produce some carbon soot, right? Unburned hydrocarbon, unburned carbon, etc. So it is impossible, right? Which means that it is impossible to stop the reaction at the moment at the formation of CO. It can form CO2, it can form C. Okay, so even though we have got a now I know it is incomplete combustion, but we cannot make sure that in the incomplete combustion agrees with this formula totally. Can you get a point? So because of we are now already given some unlimited supply of oxygen, so there of course we may get CO, but of course there may be some CO2, and also they may be having some carbon, unburned carbon that may come out. So it will give the case more complicated. So what is that? This A part. And B, draw the enthalpy change cycle with labels in which enable you to calculate the enthalpy change of combustion of ethane to carbon monoxide from these terms. Enthalpy change cycle with labels to enable you to calculate a monoxide from this carbon dioxide and calculate enthalpy change. Okay, so how you get that? So you are going to write something like this again. So I would like to draw the boxes again. So very similar, right? You may see that very often, Mr. Chin, you just draw 3 boxes. So you are going to find out what? Just follow the main equation. Just write the main equation. What is that? C2H6 gas plus 5/2 O2 to form 2CO gas plus 3 H2O. Okay? And this is what the equation they are looking for. So we have got the delta H of formation of what? Delta H of the reaction, actually. This is not formation. Delta H of reaction. Because it doesn't tell anything, right? You just give me the transformation. So the remaining is what? What is that? What is that? You can think of what? If you are thinking of delta H of combustion, yes, you may get this. Delta H of combustion. of C2H6 gas. But that delta H of combustion CO2, you need to add more oxygen. How many more oxygen do we need to have? Combustion data. 2 carbon, which means 2 CO2, right? How about XXH, which means how many water? There should be 3, okay? So you should add some O here, right? 2 times 2 equals 4, 4 plus 3, 7, 5, which means I add 1 more O2. Do you understand? Such that here comes from combustion data. Okay? So how about these on the left-hand side, the right-hand side? 2 CO to form 2 CO2. These two, they are the same. Okay? 3 H2O, they are the same. So what is missing? Yes, you need to write down this one plus O2 because I've just write down O2 here. Of course, it's O2. I need to write down here. So what will be formed? It is the delta H of combustion of carbon monoxide gas. But wait a minute, something missing. 2 per mole of carbon monoxide to be burnt. So you are going to multiply by 2. Okay? How about the one on the left-hand side? Do we need to times 2? The answer is no, no need, because the just 1 mole of C2H6. So this is just 1 mole. Okay, so you may make use of all together, all those components to form CO2 and H2O. Well, you suddenly think that you have got the right decision, right? After sitting for this classroom. Yes, it is in Form 5. It's quite different from Form 3, isn't it? Quite different. Quite different. So you need to do some calculations in Form 5. So what is that arrow? So you are going to relate those just like this one plus delta H of reaction together will should be what? The delta H of combustion of C2H6 gas, and then go back to arrow by Godwin. And this one it is minus. Hey, come on, you scare them away. You just scare them. Delta H of combustion of CO gas times 2. You have the choice, right? For those who just write down to ask your junior brothers not to choose chemistry, you have your own choice, right? Yeah. So how would you? What is the answer for this? What is that? It is minus 1411 minus what? 2 times this. So CO, the combustion of CO is minus 283. So what will you get? It is minus 845 kilojoule per mole. Okay. So this is the enthalpy change of the reaction. Got it? Got it? So for the last question, 18, do you think you can manage? Now, don't get too afraid of those data. It seems it's quite a large amount, right? You may step 4, this one is 5, is 4, is 12, is 9. Even though those numbers, they are quite big. As long as you can get the correct ratio, you can get the answer. So the question is, you are going to find out the delta H of formation of N2O4. Okay, so you may see 18A delta H of formation. Let's just skip that. Standard condition, let's skip that. Including state symbol for the reaction that represents the actual formation of this, which is N2 gas plus O2 gas to form what? N2O4 liquid. So this is the equation you're going to find. You're going to find that equation. So use this data to find out. Use the data above. Can you get a point? So you use this and above data. So what is that? This is formation. So what will you get? So what will you get? Is again, now how many times of that boxes have I drawn? Does anyone have got the tricks behind? You know it. You know it now? So what is that? We've got N2 plus 2O2 to form NO2. We've got several enthalpy data. So what will you get? What will you get? That is N2 plus 2O2 to form N2O4. Okay, this is what we would like to find, the delta H formation N2O4. But for the others, what will you get about the enthalpy terms? A very long enthalpy terms, right? But this is not, do we need to put it like this way? Now, if somebody would love to draw it like this way, you may make things a little bit complicated, huh? Because we have still a lot of enthalpy terms to be put in, right? So how about the use of this data? Minus 4,596, right? A very long term. So if I were you, I would not start from this. I will not start from this because it is rather complicated, right, to write down this. But once I would draw some other way, it will be easier. It'll be easier. So just like this, I would like to draw that again. And what I'm going to do is to follow the first equation, that is the delta H of the reaction, which is minus 4,596 kilojoule per mole. I will start from this because it seems easier to have a start like this. What I'm going to do, because the other enthalpy terms is just delta H formation. So what I'm going to do is to write down the elements here, okay, and fill them down for the others, and you can get what you want. Can you get my logic? So there should be 4CH3, NH, and then NH2 plus 5N2O4 liquid, okay, to form what? 4CO2 gas plus 12 H2O steam, and together with 9 N2. Okay, so the remaining, you may get it as the formation of elements. Okay, so what you're going to do is to write down those elements here. So how many type of elements are there? We've got carbon, graphite. What else? We've got hydrogen. We have got N2. We have got what? C, H, N, and then O. Finally, O2. So you are going to write down those things according to the ratio above. So for carbon, how about hydrogen? How many hydrogen? How many hydrogen? No need to write down the left-hand side. Just look in the right-hand side. It's easier for you to judge, right? 12. How about N2? 9. How about O2? 12 times 2 is equals 8 plus 12. That should be 20. So here it is 10. Yes, that's right. It's 10. So similarly, no need to double check for this part and this part, they are the same. They should be the same. Okay, as long as you write it down correctly. Okay, they are the same. So what's next? What's next is to fill down then the enthalpy terms. So N2 you need not write because of what? Because they are just element, right? Because they are just element, no need to write. But for the other terms, you can write, for example, water. It is come up with what? 12 H2O plus 6 O2, right? So what does mean by that? We have got 4 O2 here. It's such that it becomes 10. Okay, you get my point. So it is 10. So which means that for formation of what? 12 mole of H2O. Okay, you get a point. 12 mole of H2O. How about then similarly, we have got that one. 4 mole of what? CO2. And similarly, you do the same thing on the other way. Yes, that's right. Times 4. Times 4 for what? Times 4. Wow. On this guy, can you write down? Can you write down better? I hardly recognize your handwriting. Hey, hey, come on. 咁唔話得啊真係。So there's the H of formation of CH3NH. You go to buy a pen, right? Or just to fight for a place with 李彤, right? Simply because you see 李彤 has bought a pen. You just follow 4H2. Okay, 4. Okay, there should be what? This is from the element 4 carbon here. What else? We will call 4 carbon. How many nitrogen? N2. That should be H, right? There should be H, right? H nitrogen. So for the remaining 10 nitrogen, they will be here. Can you get a point? We'll use what? You use about H hydrogen. H hydrogen, which means 4N2. Okay, so remaining 5, you will use it here. Later on, you will use it for the remaining parts, okay? To form this. So can you get a point? So which means that this will use this one and this. Okay, so that 9H2O we will consume it like this way. So of course, once you tell to the others, this should cross out. This should cross out. Do not get confused, right? You keep that 9N2 to be here. You have to keep it. You have to keep it. Conservation of matter, right? So the remaining is what? So the remaining is plus 5 times delta H of formation of N2O4 liquid. Okay? So you may get this one. So root 1, root 2, some of you just say that again. So what's next? So what's next? Wow, very long, tedious work, right? Very tedious work. So you may find it as a delta H of reaction here, or like this. Or maybe some of you, you just want to make it as unknown. You may start from this part, right? You may also start from this part at root 1. You may start from this part at root 1. So can you get a point? Can you get it? So which means that you are going to have 5 times delta H of formation of N2O4. Okay, plus 4 times delta H of formation of this very long term CH3, NH, NH2, right? That one, that's this arrow, which is equal to what? This arrow, which is equal to this. minus this. Can you get a point? So which is what? So which is 12 times delta H of formation of H2O, and then plus 4 times delta H of CO2, okay? And then minus delta HR. So minus sign, no, so there should be the minus something. Minus something. So very, very long term. So later on, what you're going to do, this one is unknown. This one, I would like to get it. So you are going to put this term onto the right-hand side and continue to solve. Okay, because it's too long, so I don't want to write down too much for that. I just give you the answer. What is the answer? Delta H of formation of N2O4. What is that? It is. Do you know the answer? How many of you got the answer for this?
Why?
60.4. No, not correct. What is that? No. What is the answer? No idea. All gone already. The answer is 20 kilojoule per mole. You better treat this as exercise, a very tedious work, but not the mathematics part is not so it's not too complicated, but it's rather time consuming on putting those signs from plus to minus. Remember to times, to give a multiple, and all those, they would be you should be very, very careful in your calculations, and this is in line with the equation itself. Okay, so you get it now. Again, the survey, I just press the survey. Let me know your understanding of those. Yes, this is the survey result. Let's try to see 22111. So how about the others? For the others, cannot withstand, right? Most of you cannot withstand. Yes, we have got this. And algebraic method, the using the formula, mathematical formula, 3 to 10. Algebraic formula, 7 to 8 mainly. 9 to 10, here comes more 9 to 10. 5 to 6 to 10, 5 to 10. How about enthalpy cycle? Yes, the more I draw, I find that the more confidence you will have, right? While 1 or 2 students who just try to make sense of what is that, don't worry. Okay, I will give you a chance, right, to come up with this. Once again, for those who really want to have a very small class tutorial, okay, so you are please private message me, and I would like to get it and try to come up with the to the saying together. Okay, is that clear? So I would like to stop it here. I would like to stop it here. Okay, bye bye.